All right, so let's go ahead and get started with lesson 2 on the parent functions. With this one, we're going over the rest of the notes. We're going to look at some of our vocabulary terms for this unit, our increasing and decreasing, minimum and maximum points, our end behavior, and even and odd functions, and what our asymptotes are. All right. Here's your linear function. I am crossing out everything that does not apply. You will notice a lot of these do not apply. We don't have any point where we're decreasing. We don't have any asymptotes. We don't have a minimum or a maximum point. Okay? Now, since we are increasing the whole time, it's going to be when x is negative infinity all the way to x is positive infinity. The whole time we are increasing in this case. Go ahead and see if you can figure out what the end behavior is before you continue on with this lesson. All right, did you write it correctly? Okay, let's practice reading this again. As x approaches negative infinity, y is approaching negative infinity. As x approaches positive infinity, y approaches positive infinity. Check out this graph. Do you think it's even, odd, or neither? It is odd. If I rotated the picture around 180 degrees, it would look exactly the same. All right, quadratic equations. Now, a couple things I want to tell you about our quadratic equation is that I want to give you a puzzle, okay? With asymptotes, you can have a horizontal line or a vertical line. And most of the time, you cannot land on horizontal lines. You cannot land on horizontal asymptotes. Let me just start over. All right, asymptotes are supposed to be lines, imaginary lines that you cannot land on or you can't cross, okay? That is true if you have a vertical line, vertical asymptote, but you can actually sometimes land on horizontal asymptotes, and sometimes you will cross them. So with that being the case, I want you to look at this quadratic function. You land on 0, 0, but notice you don't go below that. You don't have any negative x or y values. You don't have any negative y values. So let's go ahead and write down when we are increasing and when we are decreasing. And then I want to see what you think. Do we have a horizontal asymptote when x equals 0, when y equals 0? What do you think? If you can, go online, see what it says online. We will talk about it in class and we will hold a debate about it. All right, now go ahead and do the minimum values and maximum values. Notice our minimum is 0, 0, but we do not have a maximum. Go ahead and cross that off. And now your end behaviors. I'm not going to read it to you again. You should be able to read what that says by now. And this graph is an example of an even function. Do you understand the answers that are here so far? For increasing and decreasing, please remember two things. You always start on the left of the graph and move to the right, and the increments are only the x values, not the y values. All right, our next parent function is our cubic function. Now it's your turn. I'm going to cross out everything that does not apply, and I want you to see if you can fill out the rest, and we will check your answers in class tomorrow. Oh shoot, I forgot. I lied. Once you've filled it out, then you can check your answers. Do you have any questions? Do you understand it? If you have questions, write them down. We can look at them tomorrow. All right, exponential functions. With this one, it definitely has an asymptote. Remember, the graph is approaching 0, not negative infinity. Okay? I've crossed out everything that does not apply. Check your end behaviors, and you're increasing. And I want you to write down what you think the increments are for when it's increasing. Notice decreasing, minimum, and maximum have all been crossed out. See if you can figure out the increments for increasing. And we'll check those in class tomorrow. All right, with this one, these two exponential functions are very similar. We are going to discuss tomorrow how these two compare to each other. Notice this time we're going to cross out increasing instead of decreasing. And it still has a horizontal asymptote at y equals 0. The end behavior is pretty much the same. Actually, no, it's not exactly the same. So if you need to compare the end behavior for this exponential function and the end behavior for the last exponential function, see if you can figure out what the difference is there. And I want you to decide whether these graphs are even, odd, or neither. And prepare to share your ideas in class tomorrow. All right, absolute value. By now you should be able to figure out most of these answers. Remember, absolute value and quadratic formulas are very similar. They both start at 0, 0. Whoops, I went too far. Anyway, I want you to figure out the rest of it and then be prepared to share your answers and debate your answers tomorrow. All right, moving on to our rational functions. Rational functions can be very tricky. At first, when you look at the graph, it looks like it is increasing the whole time, but it is actually only decreasing. Notice there's a gap in the notation for decreasing. Oh, sorry, I guess I should show you the answers for decreasing. Okay, so you have this little gap. So what do you think happened that allowed the graph to jump the y values from negative infinity to positive infinity? And how can this happen without the graph increasing somehow? So this kind of puzzles a lot of people. I want you to relate the situation to Star Trek. Okay, some of you may have never heard of Star Trek. If not, I want you to look on YouTube for some Star Trek video clips. And in that TV series, Captain Kirk often says, beam me up, Scotty. And he gets beamed to a different planet. And like all of his molecules dissolve and he just goes to a different planet. Okay, so this graph doesn't increase to positive infinity. It just gets beamed up there and then it decreases again. So we're not increasing at any point, but we do have two asymptotes. And here they are. Notice our horizontal asymptote is at y equals 0 and our vertical asymptote is at x equals 0. Okay. Let's look at the end behavior. You should be very familiar with this. Notice it's both end behaviors are when, your y is always approaching 0. It's not going to approach negative or positive infinity. All right, so how are we doing? Do you understand our answers so far? And what do you think this graph is? Even, odd, or neither? Once you write down what you think, then continue on and see if you are correct. All right, how are we doing so far? If you wrote down the wrong answers, do you understand why they are wrong? If not, be prepared to ask questions in class tomorrow. All right, try to answer this one all on your own, and we can go over it in class. All right, so I'm going to cross off everything that doesn't apply, and then I want you to fill out the rest on your own. All right, now before you fill out the answers for your square root function, look at your table and look at your answers for your other parent functions and see how you do. I've crossed off everything that doesn't apply. I want you to do the rest. And here's our last parent function. Can you do it all by yourself? Give it a try. You don't have to have everything done correctly. We can go over everything tomorrow and you can check your work, but be prepared to show me your parent function notes completely filled out when you walk in the door tomorrow. If you don't have them done, then you will not participate in any of the class activities. And you won't be able to have as much fun. I'll just give you lots of worksheets. All right, so last, before I end this, I want to point out that even though all the vocabulary terms were included for each parent function, one of the terms wasn't used at all. It was crossed out for every single parent function. I want you to look through your notes and see which one was crossed out every single time. And I will see you tomorrow.